Hello everyone, this is Sabiuddin Ahmed Siddiqui, and now we are continuing with the next tour of Applied Information and Communication Technology for A2. Component code is same 9713 GCE A levels A2. Now before I proceed, a bit introduction about myself. I have done Masters in Computer Science and Diploma in Computer Science and have been associated with different educational fields. And as far as education management experience is concerned, I have been associated with Beacon House School System, where I am teaching ON A levels computer science, Edupedia World Video. I am working on Java for computer applications, the City School, OA levels CS computer science, and AppTech computer education, where I am teaching computer applications on Java, Android, C#, VB.NET, SQL, ASP, etc. And as far as my profile experience is concerned, you can see that I have been associated with networking, where I deployed fiber optic at Divan Sugar Mills, Koski, and Aramax Nissan Motors, Chevrolet Motors, and networking deployment at KSA Kingdom of Saudi Arabia. Now as far as you can see, software development, there are different softwares being developed by me. And as far as my team, an online course, let's suppose, published on Java programming, and research and development on Android application development and Java and OA level students course material, where I published some books and some articles. And as you can see, this is my brief introduction. Continuing with the session. Now the session includes database, where I kept some topics of database structure, flat file system, relational database, relationships, normalization, which includes first NF, second NF, or third NF. So starting with database structure. Now first of all, you can see, and we need to know about what the data, and we are working and we are handling the data, so we must know about what the data is and where does it come from. So data is derived from the Latin word datum, which is singular, and data is plural. So you must be well aware of data, which are raw facts and figures gathered from various sources and presentable and inactive. They are scattered. That means you cannot get information, you cannot infer any structure about this thing, that this is an information. Or if the data is written, or let's suppose things are scattered somewhere, so this is the example of the data, that different fields and items are anywhere, but you have to collect that data and you have to structurize the data, and then that becomes the information. Now moving on to what is information. Basically, if you would like to understand what is the meaning of information, so information is an organized collection of data, where you can see the expressions such as information equals to data plus structure. So if you keep this information in your mind, you can see that yes, information can be formed while giving the structure to the data, because data itself has no meanings. It is a scattered form. So when you put a structure and put the items in the structures or field structures, so you will see that this becomes the information and it will give you the meaning too. Now moving on to the database structure, the first thing which is known as database. Now we say that database, what is data and base? Database means a collection of related files. File basically is a collection of related records, and a record is a collection of related fields, and a field is a collection of related characters. And you know that characters itself a collection of related bytes. And if you talk about the byte, a byte is a collection of 8 bits, and if you talk about the bits, is a binary digit, that is 0 or 1. So this is the structure of database, where you can go from top to bottom or bottom to top. So basically we go from bottom to top. So bit, byte, characters, fields, record, file, and database. Now moving on to file system, flat file system. Before the advent of database, there was a simple flat file system that is very difficult and typical to adopt. Now programmers used to write a routine and where the filing was introduced and all the data was flat and all flat databases were there were nothing like that, and including, let's suppose if you have a record room, so you have to keep a person who can bring the records, and you keep on searching the file documents and everything like that one after another, and in this process you just complete your whole cycle of the day, and then the data is still not found. So this work is reduced by the database, and database took over to the flat file system. Now a file system which used to work for all the fields at one place, irrespective of that the fields or field are repeating and creating data anomalies, where data anomalies means the complexity of data, which field to be kept, which field should not be kept, or which field, let's suppose repeating. Let's suppose if I have to add my qualification or something like that, let's suppose if I am a student, so if I want to just take number of tests, so how to store the number of tests in one account? Let's suppose if I am the student and I want to store all my progress, so this becomes the anomalies for the users who used to store the data. So all the data were saved in a large table, and for example to add one thing, they had to add the whole record as new. So this becomes the data redundancy and data anomalies. That means which data to be kept or which data to be removed. So this is why flat file system was very tedious to work with, and it was very complex too. So now moving on to the relational database system, which took part in it and reduced the errors and anomalies, data anomalies and redundancy of data because of relational database, and it kept only the data which is related to the person. And you can see that each record and each identity or entities is related to the one record, and let's suppose if the record information is repeating, then the new table will be created and all the information will be kept in separately. Now the keys concept which we have while understanding relational database, the one key is the primary key and the second one is the foreign key. Now first of all we are just discussing these two keys only. That means what is the primary key or what is the access key and what is the foreign key. Primary and access key are the two names of one key, that is known as primary key. As far as the foreign key, which is the foreign key that follows the primary key. So this is what the foreign and primary key concept, and in each table there is one primary key only. So if you have this information correct, so you can easily normalize the tables, or you can see the tables have been set up normalized, or it becomes easy to store data or handle data. A relationship can be created to link them together as shown by the lines linking the tables below. You can see I have demonstrated three tables: the table customer table, appointments table, and the pet table. Now this is the example. So you can see that the customer ID is the main file, let's suppose. So it has one record or one ID or the unique ID. To assign the primary key means the ID remains unique. That means it cannot be repeated, only the one ID. Let's suppose you have social security number, you are the one only. It cannot be repeated, it cannot be duplicate. So this is why it can be of that type, that yes, this is the unique key. A primary key is a unique key. Now on the other hand, you can see appointments table, where you can see the appointment ID is written, is highlighted and is bold and is prominent. Now the connecting key, the foreign key, which you can see here, let's suppose this is the customer key. You can see the customer key, you can see it is connected with the customer ID. Here you can see this is the customer ID. Now it has one to many relations, because customer ID or customer can come many times. That is why this is named as appointment table. How many times you have taken appointments with the doctor, so you can see that it has one to many appointments. On the other hand, you can see the pet table. Yes, pet ID is unique ID. pet name and pet type. Now you can see this is the unique one to many. Just pet, which pet came this week, that next week, or previous week, or which type of appointment has been given to the pet, or you can see that which ID has been assigned to the pet. So the pet ID, let's suppose dog 1, dog 2, dog 3, cat 1, cat 2, cat 3, or white cat 1, white shaded cat 1. So this can be the type of name of the pet, but ID can be, let's suppose, P1, P2, P3, or 1, 2, 3, 4. It could be in any series. It depends on which type of ID the user has created for these fields to manipulate. Now pet ID, you can see this is a repeating ID. This customer ID is the repeating ID. This pet ID is the repeating ID. That is why it has one to many. This infinity sign means it shows that this ID is the one to many relationships, or the repeating ID. That means it will keep on repeating on the certain number of times when the customer or patient keeps on coming on the basis of several checkouts or checkouts or checkups. So you can see that this is the field which is a type of repeating ID. So this is why we keep the relational database, and it will store the information only with the concerned person or animal or pet or something like that. Now you can see the relationship. We have basically some types of relationships, that is one to one, that is the first role, basically husband and wife, one pen and a user. One to many relations, that is one book, lots of pages, one to many, and one teacher, lots of students. Then many to many, when comes on to the many to many relationship, that means many teachers have many students, or many books have many publishers, or many books have many pages. So this could be in these terms or categories. So basically this is these are the relationships types. Now the next one is the normalization. This is very important part of the database creation and development. Now first of all, you are seeing that first NF, first normal form, then second NF is known as second normal form, the third NF, that means the third normal form. Now we will take a look of each one by one. Now see the first NF, first normal form. Now what does it do? Basically it validates the table. For the valid table, separate the repeating groups, that means which I have just explained you. Let's suppose if you want to add a correction or want to add something new to the concerned record, so the new record you have to add for updating the record, so that creates the anomalies. To remove anomalies, we should have a valid table and separate repeating groups. That means only one group can repeat. Let's suppose if you want to repeat the qualifications, so qualification will be added. As you can see, the pet ID. So pet ID, let's suppose how many times the pet will come to examine, so definitely it becomes a patient. So patient ID can be repeating, but the patient record only one ID with the repeating ID. That means the repeating table that will hold the information about repeating values. Now cannot be further decomposed. It cannot be further decomposed. That means further elaborate. That means it can be gone in further low level. That means let's suppose if there are fields which can be divided up to some extent, let's suppose you have 16 or 20 fields, you have divided one table in, let's suppose 8 fields, second table in 4 fields, and the third table in 4 fields. That's so you have to decide with the vision of that. You have to keep the foreign key and primary key in both tables, and you will be connecting each relationship with the master table. Unique key, yes, primary key is the unique key. It is underlined. You will always see that it is underlined. It has been identified for each row. Then on the 4 level, that you can see that all the attributes are functionally dependent on all or part of the key. So you can see the tables. I'm going to explain it now. Now you can see that we have order table and we have order details table. Now you can see the order number is underlined with the key. Here you can see the picture of the key. Now, and you can see the order detail which with the 2 keys. One is the order number and one is the product number. So product number is the primary key of this table, and the order number, which is the linking key and the repeating value of the order key, which is stored in order details. Now so when I connect this field, so this becomes the one too many records. If I want to connect this order detail product number with the delivery, let's suppose, so you will connect this with the delivery. So product number, how many product numbers have been ordered, so this can become the delivery table. So how many deliveries you have made, for which address, for which product number, so that can be done separately. So this is the first NF. Now coming on to second NF. Now a table is in a second normal form 2NF when all non-key attributes means which are not the primary key or not the foreign key, are fully functionally dependent on the entire key. Entire key means, let's suppose one table key, primary key is called and they are all linking together and you have called separately with the SQL query. So this makes the table retrieve data in from all tables connected each other. Now you can see order table, then you can see order details, and you can see the product. Now you can see that there are different fields available. Order number, you can see the orders reference you can find easily in order details. Now you can see this order number is connected with order number. Now this is one, this is many, right, because orders can be placed many orders. And you can see find the product number. Is there any product number? Yes, this is the primary key. This is 1 to 1 only one product, right? So this becomes the order key. So order detail and product. Now third NF, so you can see that you need to ensure that no none key, that means attribute depends on another non-key attribute. The first name, last name, passport number, address, region, postcode and country attributes all depend on a customer number attribute. Is there any customer number? Yes, customer number is there. Order, customer number, order. Yes, this is the customer number. Yes, this is the customer number. So you can see that customer order number, where is the order number? Not in this table. Order number, yes, this is here. So this is the primary for this and this becomes the order. And now customer number is here. Now you can see customer is here. So customer number, and you can see that the third form you have finally solved the problem in third form, not on the order number. You can see that attribute. Now I am again reading this. You need to ensure that no non-key attribute depends on another non-key attribute. The first name, the last name, passport number, address, region, postcode and country attributes all depend on the customer number. They all depend on customer number, right? If the customer number is there, that means all the information contained in different tables, let's suppose customer, order, details and product. So if you type in customer number, all the linked information will be populated in a way you want it. Then not on the order number, they are not based on order number. That means if you type in order number, nothing will populate the data. No order number is set to bring all the information. Now you are ensuring that an entity holds only the information related to it. You can see that you are ensuring that an entity holds only the information related to it, only the thing which you are requiring that will be populated, otherwise it won't retrieve, it won't send the data to the display unit. This table finally be in third NF. You can see this is the third NF, one primary key, second primary key, third, fourth, fifth. Then you can see these are four keys, but one has one to one relationship and one has one to many relationships. So this becomes, when you combine that relationship and when you test it, this will produce the result according to first NF, second NF and third NF. And hence the third NF is the stage where your all requirement, all decomposition of the tables are almost done, or you can say the 90% work is done till third NF. So I hope you will like this. Thanks for watching.